So let's get started. Welcome to the last session of the day. The last one that's going to talk about carrier VoIP security. You've maybe already seen quite a number of voice over IP talks during the day. What I'm going to do is trying to focus a little bit more on the telecom operator side of VoIP, what we do, and trying to show you how different it is than just buying some service from, I don't know, VoIP Packet 8, or moving to basic SIP client or using Skype or this type of things. You're going to see early in the presentation that's a pretty complex subject, so I'm trying to put a lot of kind of high-level architecture information to maybe go through a little bit of the things, explain you how the things have changed when you're coming from the traditional PSTN world and moving into voice over IP. We're going to keep the Q&A for the end. I think we should have plenty of time at the end for a Q&A session if you guys have some questions. I work for Colt and have been speaking quite a number of times at Black Hat, so it's not my first one. Colt is one of the largest telco in Europe. We serve 14 countries and have quite some fiber in the ground over there. And our voice experience is kind of interesting because we already looked at three of the major vendors that also sell things in the US market. One was, I'm not giving you names because they may be the because some of the comments I may made. So one was coming from the TDM world, so the old school type system. One is coming from the IP world, so it's basically a company that's selling a lot of routers and switches, put a name on top of it. And one that's a voice over IP company, so their main product range is actually voice over IP products. And believe me, we went into quite some surprises. We deliver those voice over IP services either over the internet or dedicated MPLS VPNs. And since I actually sent the presentation, I've updated it because we have been testing 7 new vendors in the lab to actually see what they're up to and how they can deliver new services and so on. So it's kind of interesting. Things are moving, but you're going to see through the presentation that you still have a lot of legacy and security bugs you guys expected probably 10, 15 years ago, but they're still around. Just going back to the 3 vendors we actually used to work with, or we actually still use two of them. The one coming from the TDM world, it was pretty clear they had no idea about what IP was. So they knew their voice stuff, but as soon as you were talking about networks and security and so on, I mean, their experience was fairly limited, and after like a 6-month trial, we actually shut it down. The one coming from the IP world, they have a lot of equipment that used to sit and run the internet, so security-wise, they're pretty good. They're not perfect. IP data-wise, pretty good. Security, they're getting there. The voice over IP company, they're actually well known in the US, but they deliver a lot of services to the enterprise world. So, moving something from the enterprise world into a carrier world is completely different. When you look at it from a security point of view, it's being exposed, to the internet. It has to be multi-tenant. You're not going to build one infrastructure for every single customer, so you need to be able to virtualize things. You also see that all their applications, they've never been exposed to the internet. So, the trust model they use is still, it's an internal LAN and nobody's going to attack us anyway. So, quite some challenges, and we have been working nearly full-time with my team on VoIP for the last 18 months now, so we're getting bored. So, what do you guys think VoIP is? When I'm talking about some people, what's VoIP? They see voice over IP as basically either having a hard phone connected to their cable or DSL modem, and that one is talking SIP, with something like VoIP Packet 8 or SIP call or any of those providers, or either running Skype on the laptop, and that's about it. So, and what happens, behind, they don't care anymore, and that's actually where the fun starts. So, first example. So at the top, let me use the mouse. So you can you see the mouse now? Yeah. Okay. So here it's just a basic example. On the left-hand side, you've got the carrier with a typical class 5 voice switch. You have a physical E1 line going out to the customer. The customer's got a PBX sitting on the right side of the screen over here. and he's got phones. That's the typical voice setup you have, in an enterprise connected to a carrier. Okay. As soon as you move that one into the IP world, things changes and actually become more complex. So first example on top, you've got those IP phones on the right-hand side. They are hidden between CP. CP means customer premises equipment. The DSL router you used to have at home, the cable router, those type of things. You're connecting over the internet to the carrier. The carrier is protecting and doing some other fancy stuff in front of the hosted PBX using an SBC. An SBC is a session border controller. I'm going to come back into the details about what an SBC is. So just keeping in mind, it's something like a firewall sitting in front of the hosted infrastructure. So behind there, you have the IP PBX sitting, and that one's connected to the TDM world, so the plain old telephone system. The example at the bottom is actually nearly the same. The only difference is that on that CPE, you don't do that. That means that all the phones sitting behind the CPE have public IP addresses. That doesn't happen too often. But when it's the case, you may not require an SBC, and you can live with a simple firewall in front of the hosted PBX. Again, you will understand a little bit more when you get into the details about what the SBC does and doesn't do in the upcoming slides. Another example, at the top, again, a typical setup, PBX trunking of IP. As you can see, there's no difference between the two slides. Because physically and technically speaking, in the plain old telephone system, the physical setup is actually the same. When you look at the bottom, the voice of IP equivalent, you see that to provide exactly the same service we used to provide with like 2 boxes and 1 physical line, you require quite some equipment. You have lots of new protocols coming in and things you've never seen and things I have never seen in the past either. So, you take just to be able to provide the same service you would expect when you pick up your phone. The voice of IP equivalent is way more complex. I've got some example on the top side, right? So what you need usually when you pick up your phone, you want to dial a number. You may access voicemail. To access voicemail, you need a PIN. To be able to enter PIN, you need DTMF. That's already something that's pretty complex to do in the voice of IP world. The next thing that's driving a lot of people nuts is fax. Fax over IP. Telephony over IP is not just about making phone calls. It's also being able to send and receive faxes. So again, something that is very basic in the plain old telephone system world, is very complex in the voice of IP environment, because you need another protocol, which is T38, to be able to send and receive faxes over IP. And then again, in your enterprise, usually especially if you're a small SME, usually you're going to outsource the management of the PBX to another company. So that company needs to be able to access it from remote and do changes, maybe update the accounts, the phone numbers, and so on. And to do that, you need a feature which is called 64K unrestricted. So that's basically the data channel that you guys need to access the PBX or management. Again, in the voice of IP world, it's a fucking nightmare to set up. And I'm being really gentle. We've been fighting with this type of things for months and months. And, the feedback you usually get, just get rid of your bloody firewall, he's causing the trouble. Anyway, on the hosted side, you have a soft switch. The soft switch is the system that provides the intelligence, call routing, contains the user base, it's where you're going to authenticate, it's going to know where to route calls, depending on the number you dial, and so on. So it's basically a router for voice of IP traffic. And that one is going to talk MGCP, which is another protocol, to the gateway. And the media gateway is the equipment that actually, takes the encoded voice and, transforms it again into a normal, analog voice. That's the component that actually converts all the data. And as you can see, lots of protocols still between all those equipments. So between the customer premises equipment down here, where the PBX is connected, that equipment needs to talk H.323 to the soft switch to be able to do all the call signaling. It needs to talk RTP to carry the encoded voice. Yeah, that's not the best approach, right? So on that side, behind the firewall, again, You need to talk HTTP3 to the soft switch for all the signaling. The soft switch needs to tell the media gateway when to dial the number, when to let the voice through, all this type of things. And I also had another protocol, again, MGCP. Usually MGCP is only between a soft switch and a media gateway. But in some cases, you actually need to feed back MGCP information back to the CPE. And that's in the case of advice of charge. So when you expect your phone to display the cost of the communication in real time, you need your soft switch or the media gateway to feed back MGCP information to your phone. Again, seems really simple on the slide. It's a nightmare to deploy. Okay? As you can see, we're moving from something really simple on top to something very complex to actually deliver the same service. Okay? We're not going to get into discussion here, is it really cost saving or not, We're not talking business cases here today. Another thing that a lot of carriers do is resell voice minutes. So a large carrier is always going to sell, what you call in the IP world transit. IP transit, you're going to do the same thing for voice. So all those the large voice carriers are being interconnected, and you're going to resell, this connectivity and this voice minutes to other smaller carriers. Again, seems fairly simple. So on top, you can say, on the left side, we have cold, we have the voice switch, we have a number of physical lines. Each E1 can, for example, carry 32 calls. So, depending on the number of voice minutes you want to sell, you have to set up more physical lines. And on the other side, the customer, again, with a simple voice switch and then his network behind. Seems fairly simple, right? Look at the bottom. Doing the same thing using voice over IP. How can I explain that one to make it simple? I actually put two examples. So the way people used to do it in the past is just to take a media gateway. So that's the bottom part here, okay? They just used to take a media gateway, so a component that converts, the encoded voice into analog voice again, connect it to the voice switch, put it somewhere on the internet, and then, you could resell voice over IP minutes over the internet. That's, for example, the way most of the Skype in, Skype out stuff is being deployed. Okay, so if you use Skype and have their Skype in, Skype out feature, they're not a telco, right? So they're going to buy minutes from somebody like us, and we're just going to connect them to such a voice gateway. At the end of the day, if you know the IP address and some information, you could actually abuse that gateway. Okay. The newer setup, people moving away from HTTP3 going into the SIP world on top. Same approach as we saw before. You have an SBC in front to deal with some security. Again, I'm going to give you the details later on. Talking SIP. In that case, the soft switch. The soft switch tells the media gateway over MGCP, how to deal with the traffic that's coming in, and then you have RTP end-to-end between, on the far right side, the customer of that other carrier. So maybe you using Skype out, and going RTP to us, and then into the TDM world, and establishing the call to the far end. Okay. I hope you understand it. I mean, I really try to simplify it a lot to make it, easy to understand, because you're going to see on the next slide, that's how it looks for real. And that's still the high-level view, right? The visio we have of the network diagram for one single POP doesn't fit on an A3 page, right? Okay, and we don't have all the information on it. So what I did here is just show you the high-level view of one single voice over IP POP we have in the network. So I'm not going to go into the details again. The only difference between all the single example and that consolidated example is that I had it on top, all the OSS and BSS stuff. And that's where it also becomes interesting, because you have all the web-facing systems, to do the online code provisioning, the online user provisioning, to download code detail records, and so on. So all those platforms, they're exposed to the internet. And as you're going to see later in the presentation, all those guys, they've never heard about voice over IP security either. They haven't heard about web application security. So at the end of the day, it may be way easier to get information about customers, including, maybe some voice records from one of those web applications, and trying to break into the network and do things. Okay. Just a quick one on the protocols. I'm going to focus, as you could see from the previous slides, most of the carriers still use HTTP3, which is an ITU-based protocol. It's ASN1. Okay, you remember ASN1 from school? This crazy mad protocol that nobody can decode and encode. So those I mean, those systems, being in the firewalls or the SBC, they need to be able to handle, ASN1 encoded messages. And as you can, expect, lots of issues with dealing with it. The two main protocols then they use are H.225 RAS and H.225Q931. The first one is just to maintain the registration information between the phone and the gatekeeper, and the other one is used for call setup. So every time you make a call, you actually have a TCP session being built between the phone and the gatekeeper. The other one is MGCP. MGCP stands for Media Gateway Control Protocol. So as you can see from the acronym, it's really there usually only for the soft switch to control the media gateway. And the only reason you would see it somewhere else is usually for address of charge. Okay, in the MGCP world, which is coming from the IETF, there's an RFC. The soft switch is called the call agent, and then you have like two things running on top of UDP, port 2427 and 2727 between the media gateways and the call agents that control the media gateways. Okay. SIP, is again, an RFC, IETF. I actually have like 10 or 20 versions of SIP with all the extensions and all the vendors. It's HTTP-like. I'm not going to go into the details. If you're interested in VoIP, you've probably seen some of the VoIP presentations today. And Henrik and Dave and the other guys probably know more about SIP than I do so far. The other protocol you're going to see a lot is RTP. That's the media stream, right? It's the encoded voice you're going to carry between the end system and the media gateway. The codec is the definition on how to encode voice. So what you know from ISDN, that 64K clear channel is G711A or U. And then G726 is a mix in between the two. So that one is like a 32 kilobit codec, and G729 is actually GSM codec. So that's 8 kilobit per second. So depending on the quality you expect, you may actually pick one of those codecs. Okay. By default, all those protocols are clear text. H.2.3, MGCP, SIP, RTP. So unless your vendor supports end-to-end security, usually you won't see SIP TLS, you won't see secure RTP, and so on. And in the carrier world especially, we're still far away from being able to support those protocols, just because the hardware doesn't scale up because of all the crypto stuff you need when you want to do it. Usually RTP, to be able to identify it, you either look at the port information. Usually it's 16,000 up UDP. If you can see the signaling, you can actually find out if it's RTP or not. And two options. It can be directly between UAs. UA is a user agent. User agent can be hard phone or soft client. So it can be directly between two clients. That's what you call free intersite calls, when the signaling goes to the carrier, but the RTP goes directly between the customers. There's a risk of fraud, so many people don't do it. So what people usually do, they backhaul the RTP traffic always from the user agent to the media gateway and then push it back to the other user agent. Okay. So direct communications usually don't happen that often. You always go over some sort of media gateway. Okay, some more details on the SBC, because I think some of you may actually never heard about it. So the SBC has quite a number of roles. Security. It's a little bit like a firewall. It's going to allow RTP based on the signaling, because it's like kind of man in the middle, can inspect all the signaling, and then at the end of the day decide if he sees RTP traffic between the media gateway and a customer, if that one is allowed, or if the customer is trying to abuse your voice gateway. So basically the same approach as a firewall looking at FTP, at FTP control channel and then opening the data part for FTP. The other thing that's kind of important for an SBC is what is called hosted NAT traversal. Hosted NAT traversal is a function in the SBC for it to correct the signaling information based on the IP header. What happens is that the IP information of your phone is being embedded in the signaling. The problem is usually you're behind the NATing gateway, so your CP is going to hide the private addressing you use behind the public IP address. The SBC, the soft switch, the media gateway, to be able to actually route the call and the packets correctly, need to make sure that they can find out when 10.0.0.1 is trying to call 10.0.0.1, That's actually two different customers behind two different netting devices. So that's the role of the SBC, to actually make sure that the IP header information is being kept, that the signaling is being fixed, and just to keep that state information somewhere in memory. The other thing an SBC does sometimes, it's not that common, is convert signaling. So you can have internally, you can, for example, speak SIP only. That's a requirement if you have an IMS core. And on the external side, facing customer, you talk H.323. So one of the SBC functions is actually to convert all the signaling between SEP and H.323. It can also convert media. So if you're talking G711 on the internal side, but you want to save bandwidth on the external side, and you want to use a G729, well, the SBC can also take care of the conversion. Again, you don't see that often. The SBC can be located at different places in the network. Usually, you put it in front of your voice over IP core, which is facing customers. The other place where you use it quite often is between different providers. So when we want to interconnect with another big provider, we may actually put an SBC to control what kind of signaling is being exchanged between us. There's an alternative to the SBC, and you've probably seen it for some of the slides, because sometimes I was using firewalls, sometimes I was using SBC. Some of the high-end firewalls you can find in the market today, they have those features already. So the security and hosted NAT traversal feature, you can find it in most of the higher-end firewalls. So if you don't need all the things like signaling conversion, media conversion, and also advanced SBC features, maybe you don't want to spend the expensive cache, the expensive stuff on the SBC, but just buy some of the standard firewalls, which is usually way cheaper. Some people also argue in the voice over IP world at the moment that all those features like security, hosted NAT traversal, signaling conversion can actually be done on the end system directly. For example, on the soft switch. It saves you quite some money. It's less hardware to deploy, but at the end of the day, it's, in my view at least, the capacity of an end system. We all know the limitations of Unix or Windows operating system when it comes to sockets, memory, file descriptors, and so on. If somebody runs a DOS attack against it, all the security features on them, they're going to crash anyway. Some people also argue a lot about, hey, why is there no VoIP network IDS? In my view, given the experience we have so far, it's damn useless, because you get so much traffic, it's so damn complex to actually keep up with the state and decode H.323, because it's ASN1, decode SIP, because SIP can be very, very complex. You can have headers and headers and headers, think IPv6, right? So, and also people, trying to push, let's go for CTLS, SSLify SIP and so on. So at the end of the day, a voice over IP network IDS is probably more hype than anything else. I probably won't put any money into it if I had the chance. The voice over IP hardware we have been looking into, it's usually a mix of software and hardware. And what you're going to see is most of the kits, when you buy kind of carrier grade kit, is mostly DSPs, because you have a lot of signal processing to do to convert the voice and so on. The soft switch, as I said earlier, only does the signaling stuff. The media gateway does the conversion between RTP and the TDM world, and usually also takes care of the signaling. So SS7 is the signaling in the plain old telephone system, and you have to carry some signaling over IP. So usually that's also the role of the media gateway. When you buy an IPPBX solution, usually the IPPBX itself is a combination of the soft switch function and the media gateway function. The ones we have been looking at are mostly real-time OSs, at least for the media gateways and for the PBXs. It's being QNX, VXWorks, RT Linux, and so on. The soft switches, quite often Solaris, some Linux, some Windows sometimes. But those were quite fun to test because they got infected every other day. But that was back in the early days, of Blaster and other worms. What we have learned too, from all the testing and the deployment we've done, those guys have never heard of OS hardening. So you still get today, if you buy it from some of those vendors, Solaris 6 or Solaris 7 unpatched. Okay, can you believe that? Me not, but it's crazy. And then when you try to apply some patch management to it, the feedback you get is, well, you cannot put it up to date, because if you do that, you're going to break the application. So we actually have to either not patch and firewall as much as we can and put security around it, but it's just like, just kind of worms that's going to explode someday if somebody finds a way around it. So it's always funny when some of the vendors tell us, if you actually patch it, we won't support it anymore. The security challenges we've been running into have been quite large. As I said earlier, people always, when you talk voice over IP or telephony over IP or, voice over packet networks, whatever, people think SIP, okay? It's not just SIP, believe me. Most of the existing carriers that have legacy infrastructure in place, they're looking at SIP, because SIP enables you to provide quite some new services like IMS. IMS is what you see, all the fancy stuff you have for cell phones, getting video on the cell phones, doing MSN Messenger on the cell phone. Those are the type of IMS services you can see today. But SIP is a clear driver for that because, it's cheaper CPEs, you can buy something from Linksys or D-Link or Netgear or whoever, for very cheap and it's talking SIP. And getting the equivalent talking H.3 is usually much more expensive. The craziest thing we've been running into over the last 2 years is what I call voice over IP dialects. Okay, I'm going to get back to that one in a couple of slides, and you will see why. What we're also seeing is that there's only, at least in the carrier world, a couple of voice over IP stacks. Because you have some companies that wrote them and they OEM them, and so that means that some of the vendors we've been testing, we just found the same vulnerabilities over and over again with other vendors, just because they are actually buying the stack. The hard lesson we've also learned is that you need firewalls and SBCs to actually secure the infrastructure, but at the end of the day, it makes it much more complex and nearly impossible to debug. I mean. Debugging a voice over IP issue when it's an end-to-end issue, you can spend days on it. So every single equipment, you have to know it by heart and be able to actually look into it, debug, trace, sniff, and so on. The other thing, but that's more scalability issue or a capacity planning issue is making sure that you actually can handle the number of calls per second you require in your environment, and that you can deploy quality of service end-to-end. Because if you have a single segment somewhere in your network that's not QoS enabled, you may have quality issue and they will be impossible to fix. The other point is is voice over IP one more backdoor? Okay, so I have lots of things on the slide. It's actually a slide I reused from an earlier presentation about enterprise security. So, about all the backdoors you have, people coming with external laptops, your CEO and CFO, they want, to use wireless LAN, the remote maintenance into your mainframe systems, all the remote access you have, and and then in front you have all your big firewalls where you put a lot of money, proxies, antivirus, anti-spam, and so on. And then you have this nice voice over IP thing you buy from a provider. No firewall because you cannot firewall it. It's sitting somewhere in the network. It's not the same team running it. It's plugged somewhere in the network, and that means that you have to fully trust the provider. Otherwise, you've got an issue. And what we see, I was quite surprised because quite a number of customers didn't even ask us, what do you do to secure it and make sure that customer A cannot talk to customer B? But it's something we look into. So as you can see in the VoIP cloud, some of the equipment is actually dedicated. So in that example that I put here, the IPPBX is actually dedicated for that customer. But then you have some other systems like TFTP server that you use to update the firmware, to store address books and so on. Usually those are shared between customers, right? So if customer A can break into the TFTP server, well, he can reach all the other customers. This type of things that you need to keep in mind. And when you guys buy a voice over IP solution from a provider, ask them, what systems are shared and how do you make sure that if somebody breaks into a shared system, you can just hop into my network? Because believe me, you won't be able to firewall voice over IP traffic. We have a hard time. Most of the people in the enterprise world, it would be a nightmare for them, and then you run into support issues, how to find out where it's broken. Is it us? Is it you? Is it somebody else? So keep that one in mind. What's the voice over IP dialect results at the end of the day? Well, every single vendor we've looked at has changed the protocol in some way. So, you have those nice things, H.3 with ITU definition, MGCP, with IETF, SIP, which is IETF, and so on. We have RFCs, and then you put your firewall. You say, oh, your firewall is able to deal with H.3. Okay, it doesn't work. You start to sniff the traffic, you look into it, you talk to the vendor. Oh yeah, by the way, we changed a single bit down there because we need it for something else. And then your firewall or your SBC can't inspect the traffic anymore. And the result is pretty clear. So you either don't put a firewall and leave such a system like Solaris 7 unpatched, naked on the internet, or you find some workarounds. And some of the workarounds are quite ugly. What I've seen deployed is people, they take a Solaris 7, NFS, DC, RPC, Open, all those nice ones. And they just do, oh, RTP is UDP, so let's just permit UDP any to that system. Who cares, right? And then they wonder why people get owned, they get rootkitted in less than 24 hours. Okay, so make sure that if you actually want to firewall such solutions, don't forget that quite a number of the systems, they were just stock installation of operating system applications, and that permitting large, even UDP ranges, may actually expose quite some information in some vulnerable systems. And then again, some of the vendors, they've never heard of timeouts and don't send keep alives. So, they just expect, oh, we sent some signaling 2 days ago and the firewall still probably knows about us, let's make a phone call. And then they wonder why it's broken and doesn't work. So all this type of thing, you just realize after some time that all those protocols and the implementations the vendors have made of them are just not firewall friendly. How to do low-flow intercept? I got this question earlier, so I'm going to cover it. I did quickly. Low-flow intercept is kind of easy in the voice of IP world. People seem to think, because there are a lot of discussions about, people, we need to be able to sniff voice of IP traffic. We need to be able to do low-flow intercept. We need to follow CALEA and so on, and ETSI and whatever other standard or low or whatever. The easiest way is just to use TDM breakout. So what you're going to do in your voice of IP call, when you want to do interception of a voice call, what you do is you just route that voice call over the TDM world, where you have your low-flow intercept solution anyway, because you have to as a carrier. So what you do is just, using basic number routing, you just route the call into the TDM world before you bring it back into the voice of IP world, and you've got your low-flow intercept feature. So it's quite funny when you get some people, that write I think it was the US, right? They wrote a letter to the Senate or whatever. Low-flow intercept is complex in the voice of IP world. Well, it depends how you do it, right? But some basic things like TDM breakouts, I don't think it's that complex. I'm not saying it scales easily, but that's kind of an easy way of doing it. The other thing is, people install a sniffer, they want to be sure then to capture signaling in media stream, they store it somewhere and so on. Again, when you have like 20 POPs like we do, you need 20 such systems sitting around, not easy to maintain. And the other way is just to reroute calls using the voice of IP signaling itself. In SIP, you can just proxy the signaling as much as you want. So it's also a way to route calls somewhere in your network to bring it to a point where you can actually sniff it and then, still make the call happen. But you want to make sure that you hide this, because I don't know if you ever looked at SIP signaling, but in the header you see proxy by. So you see a nice list of proxy by, proxy by, proxy by, and when you see that for, at day one you see only 2 proxy by, and at some point you see 5, somebody's probably playing with your traffic. Okay. Eavesdropping, that's also thing, people being able to listen to the calls. I get this a lot. For us, it's not a real threat because we own the network. So if somebody is able to sniff in our backbone, I think we have more than one issue, just voice of IP, because they could just, look into everything. So that one really doesn't apply. And then I get the feedback, but in the enterprise network, we need to be able to encrypt traffic and so on. And then, you look at it from in the global perspective, and you see, they use clear text email, everything is HTTP anyway, including access to HR data, and all these type of things. And it's SNMP version 1, and they store all the files in the file server with no writes. So, why do you want to make just the voice of IP more secure when you're even running, 80% of your network clear text anyway? And then the feedback you get then is like, yeah, but usually on the phone you discuss things that you wouldn't discuss by email. Right, you don't discuss by email, you use IM. And you forget that people can log IM. So it's always a funny discussion, but it's kind of requirements we get from customers. But at the end of the day, we just have to say no, because at the moment there's really no carrier solution that can scale up. It's probably going to come at some point, but it's really fun. I got another one. I mean, it's really funny because the first one that actually asked us about it are banks. Okay, the banks, they want to encrypt stuff. but they have a requirement to be able to store all the conversations because, for legal issues, if something goes wrong with trading and whatsoever. So they want us to encrypt everything, but be able to sniff it somewhere in the network anyway to store it. So, it's just, you're going to encode and decode 2 times, and then at the end of the, at the conversation, you wonder why you got, a walkie-talkie style conversation, because of the delay and the echo. Anyway, but if you want to show it to your management that it's easy to sniff, I put a list of the tools, but that's nothing new. Another thing that's really not new is all the phones, hey, customers coming back, hey, I managed to crash your IP phone, right? We do that all the time, just by using it. They're pretty weak. Yeah, I mean, I'm serious. It's driving me nuts. I mean, some of the phones have been around for 10 years, and you just, send a ping that's too large or TCP with a different flag and whatsoever, and reboot. So this is really no news. I mean, you can probably look at the archives for Black Hat. I don't know how many talks there have been already about, how to break Cisco IP phones, and look at some presentations from Ophir from 5 years ago and so on. Anyway, it's mostly an insider threat, right? And what's funny is when people, start to exhaust the HTTP server resources, and the phone can't boot anymore. So, the phone system is down because the HTTP server is down. We got a nice one with the customer. We got a major escalation on a Sunday, right? And it was a call center that didn't work anymore. So I think 600 or 800 seats. It happened that the DHCP server was running on the laptop, and the guy went home with the laptop. And we had to, I mean, that was like, you're laughing now, right? We had to send people on site in Spain to debug this. So yeah, the guy was gone on holidays and he took his laptop. It was on the DHCP server for the whole company, not bad. TFTP server, so that one, as I said, is usually holding the phone configuration, clear text with the PIN. So, you got a PIN, you access voicemail, you can change the call routing for that person, she's not getting phone calls anymore. Yeah, right, because you're getting them. So lots of fun things to do. So all the credentials usually are stored clear text, don't think MD5 hash, crypt hash, it's clear text. And if you want to try 000, 1, 2, 3, 4, 4 9s, whatever. People don't learn. And usually what you see is that you can try as many as you want, right? How long does it take, you think, to try from 4.0 to 4.9? More than a second. If it doesn't crash, well, you try. Okay, just a little bit making fun. The other thing, I want to make as a comment, doing voice over IP doesn't mean that you need to move to IP phones, right? As you have seen some of the examples in the beginning, you can just do voice over IP between your PBX and telecom company. So internally, you can just keep your normal phone system, dedicated wires, and you don't have to build a second LAN, do VLANs, do QoS, and so on. It's an option too. And if you just expect to have the same basic services you have today using voice over IP, you don't need this nice Cisco phone that you see in Alias or in 24. Okay, so we've seen people moving to voice over IP because actually you have some cost savings when you do it. But if you change everything and you just want to have just nice voice over IP phones and be able to stream, the thing about you just got a BitTorrent and send it to your neighbors in the open space, yeah, then it's fine. But other than that, you could actually keep the existing network. And at the end of the day, it's kind of good because you don't have to deal with all the issues on the LAN. You don't have to do QoS in the LAN. You don't have to run another VLAN somewhere. You don't have to make sure that people actually play with it and so on. So, I mean, it's also an option. The only thing, the issue is then you need to do something specific if you have a lot of soft clients. People running voice over IP phone application on their PC, and find a way to actually deal with that one. Some threats. The denial of service one, where generic DDoS, in our case, it's not really an issue because if you're sitting outside of our network, you cannot talk to our voice over IP call. So in the beginning, we did it with ACLs. The problem is we have to cover ACLs for more than 14 countries. So it was kind of a pain indeed to maintain. And what we do now, we use edge-only BGP black calling. So we use BGP's border gateway routing protocol, so the one that's used to carry routing information in the internet. And there's a trick where you can actually, on the edge of your network, drop all traffic coming from outside to some specific IP addresses internally. That's the trick we use. So that one's pretty good because even if you have new IP ranges for customers, well, they're still inside the network, so you don't have to maintain those lists. So that one's pretty well, doing well. If somebody does a DDoS from outside, the router drops it without any CPU impact, so that's pretty good. And even when somebody plays with it, we kind of used to large DDoS attacks, getting 10, 15 gigs of DDoS attacks and packet load a day. You know, we're used to that, so we know how to deal with it. The denial of service that are more of an issue are the ones generated by customers. And I actually wrote they are not too difficult to trace. I think I'm going to change my mind given some recent experiences. They are difficult to trace because you will need to sniff 24/7 to actually see all the details about what's going on. The issues we have seen so far are protocol layer DOS attacks, where the customer just takes out the box, we put it in his premises, he's using a soft client, put his laptop, takes some of those nice tools, to run SIP attacks, and does that. And then, sometimes when he's lucky, he's just going to break the SPC. It's okay. Sometimes he breaks the soft switch. You lose all customers. And tracing those things are really difficult because we found out that actually you can send such a packet, and it's going to take 3 or 4 days for the SPC to crash. So how do you want to trace back what's going on 4 days before? So all those protocol layer DOS attacks, and we have been running quite a number in our lab before deploying the kit. Those are a nightmare to trace, but very easy. If a customer is really pissed off and wants to piss us off, that's an easy way for him. I think we're going to have a hard time getting there. We have also seen, as I said, the firewall or the SPC getting into a blocking state. You all remember the old TCP attack against TCP, against the state machine of TCP. Well, the state machine for H223 or SIP, they're even crazier than the TCP ones. So, you just have to find the right block somewhere, you get in there, and your whole system is stuck because of one single packet. So those are really not so gentle. The other challenges we've been running into, as I said earlier, all the online services, call management stuff, what is also called the operator console, when you dial the main number. And so that's all, sometimes an application running on a PC, sometimes it's web-based. Default password 4x0. You can do all the call routing. You can, pass conversations on. You can create new user. You can change the user's phone number. You can change the user's voicemail pin. All these type of things. And again, people want to use that over the internet, clear text. We don't support SSL. Sorry. So again, that one's kind of a security challenge. We're still working on it. And for the products coming from the enterprise world, those are very, very weak when it comes to that point. The other one, which is kind of funny, is IN routing. IN stands for international numbers, things like intelligent numbers, sorry, not international. So when you, especially 0800s, all those type of numbers, they're being sent to a specific platform, and then they're being routed to a normal phone line. If you get access to that platform, you can just, play around. You get the 0800 for free, people can call you for free, and you just send it to your cell phone, the carrier is going to pay for it. Again, those, coming from the carrier world, never been exposed to the internet, but you want to give customers access to it. And it's so funny, you can just take any bank in the US with a free number, You break into the carrier, you route all the phone calls for people doing, online transactions to your home phone. I don't know if you've seen the presentation about phishing, easy. You can get access to online reporting. You want to see the CDRs. CDRs are call detail records, who called who at which time for how long. You can learn a lot of things, It's like with PGP, people send emails, encrypted, and then you have a subject line that long. This email is about the Excel sheet, about the data that I want to send you, and then the rest is in PGP. So it's a little bit the same with CDRs, and sometimes you learn more from who is calling who at which time than, listening into the content. All the security issues we've been running into for also application multi-tenant capabilities. All those applications have been built with a single customer solution in mind. So they expect us to put one dedicated server per customer. And multi-tenant usually means, they use some JavaScript tricks on the client to actually not show you the other domains and this type of things. So at the end of the day, what I can say is all those vendors have actually never heard of web application security. So they had a lot of things to do, and we're really having a hard time trying to secure those applications. Much more actually than dealing with voice over IP dialects. And again, why would you guys need lawful intercepts or trying to reroute traffic when you can just log in with 4x0 to the web application, or using some basic N1 equals 1, in the web front end, you get access, you can reroute calls, listen to voicemails, create recordings and whatsoever, okay? Their web application firewalls are really required, but they're just an ugly hack in front of those things. The other challenge is like, as you can see, probably understand from the presentation, the TDM and the voice over IP world, are completely different. We're coming from two different worlds. TDM world, people don't hack it that much. We remember 20 years ago when people were doing 2600 and all this type of thing, right? But it was really kind of security by obscurity, or even better, security by complexity. All those IP guys, they've never heard of the voice world, so in the voice world it was kind of secure. But we're getting together, so it's really fun because what you see, by creating the voice over IP front end to a legacy network, we actually expose some of the systems that have been around 50 years routing calls, with a very weak OSI stack, to the internet. And then, again, one single packet, you can just make a class 5 switch in the boot. And nobody ever saw that, oh yeah, but voice over IP, it's going to be a completely different platform. It's not going to be connected to the legacy voice switches and so on. Well, it's just not the case. So you can easily blow up a well-known carrier just by blowing up the voice over IP front end, because it's going to break everything in the chain behind. Also, voice over IP world, the forensics are kind of limited. There's no mapping anymore to a physical line. In the plain old telephone system, your phone number is actually linked with a physical line, so they can trace you easily. In the voice over IP world, you can be sitting anywhere and doing things. So that one's also, for all the people dealing with fraud detection and fraud and abuse, they're having a hard time, because all the call spoofing, all the spoofing you can do, the forging of the headers, sending different information in the SIP header, and it's really a challenge for all those people. And we've learned it the hard way, getting the security engineers, the voice engineers, the IP data engineers to work together. All the pushback we get from operations, because it's damn complex, like you can see. And then on the other hand side, you have marketing pushing, because time to market, you have to be the first, and you just have to deploy, and nobody's going to try to break in anyway. Yes. Okay. Voice over IP is damn complex. So yeah, the only way that actually debug all the issue is getting the right people together. And the thing you need, if you deploy voice over IP, is you need to be able to sniff everywhere. Hey, if you don't have Etherreal running on a system connected to mirror ports on your switches, you have zero chance of actually finding out what's going on. And believe me, if you don't do it, you're going to learn it the hard way. And we actually had we made a fun exercise, because we deployed, I think, an earlier version of Etherreal, because we had a specific plugin from one of the vendors to decode their signaling. And as you know, Etherreal, every other month, they have like 125,000 updates about the dissectors, So we actually played around, and we managed to exploit the Etherreal that was sniffing the voice over IP traffic over the internet. So, people then learn that, read-only span ports are kind of useful, that we need a DMZ for the sniffer. And if there's anyone in the room that actually can upload a rootkit over RTP, job is open. Okay. Some people did that with IDSs, just waiting for it to happen could be good fun. Carrier voice over IP security, that's what people also call voice over IP peering. So you have all those peerings on the internet that you know of between carriers over internet exchanges. Well, you have the same thing over the internet. It's already in place. When we sell services like TDM breakout for things like Skype in and Skype out, well, it's just carrier-to-carrier peering, and you have some form of trust. Currently, most of them are over the internet, but what you're going to see even more going forward is using dedicated MPLS VPNs or VPLS services. That's just basic Ethernet end-to-end. And then again, I'm not going to go into the details, but you have the same issues with trusting end-to-end MPLS. If you're just interconnecting network without being able to look into the content, because it's tagged and you don't want to detag it and look if the IP information is correct, if the signaling is correct, and so on. Well, those are the things that actually may give a hard time to carriers. So the rule always is, if you interconnect using MPLS VPN, you always want to break the VPN in between the carriers. You don't want to do it end-to-end, because you want an IP-IP interface where you can actually look into traffic and sniff it. You want to use the SPC features of topology hiding, so you don't want to show all your signaling information internally to other carriers. You want to use white and blacklisting of numbers and IP addresses to be able to track what's going on between the carriers. And you really want to use the SBC to do that. And at some point, if you really need to, you can even do signaling and media conversion if you need to. But I think that requirement is going to go away going forward. Encryption, authentication, I touched a little bit in the beginning. We are still discussing internally if we want to introduce it or not, given all the limitations. So when we spoke with the vendors, in the RFP, vendor X said we are compliant. I think they don't even know what encryption means, Okay, encryption maybe means you can use numbers instead of single characters for the password. I don't know, but they were not compliant at all. The other one, it's on the roadmap, but the roadmap was saying not defined. So the roadmap was going up to Q4 2007. So it's not going to happen tomorrow. And the other one, like the feedback was like, why do you actually need this? Well, because customers are asking for it. So the only alternative we have seen deployed in some larger environments is to do a IPsec between the CPE to the VoIP core. So at least, when you really do it over the internet, that you actually secure some of the stuff. And that's doable because the CPE can actually scale up because, some of the routers you can buy today have dedicated crypto cards in it. So it's not that much of an issue anymore of running IPsec on top of it. And also, you can buy quite some large VPN concentrators with dedicated crypto cards that can deal with it. That means that you cannot do CPE to CPE RTP anymore. So free intersite is gone with IPsec. You need to backhaul all the traffic to the central location. And some of the testing we have been doing, you see that you're still within the round-trip time that's necessary for echo cancellation. Because if you have too much round-trip time, you're going to get echo on the line and you cannot cancel it anymore. What we may actually do is do IPsec for mobile devices. So today, all the people we connect to our voice over IP core are fixed line customers. So we don't offer, mobile devices. So you cannot take your laptop with your SIP client and actually dial into the VoIP core. But what we're going to do is force IPsec usage for this, so that the only thing bad guys sitting outside of our network can do is attack the VPN concentrators. But at least all the directly connected customers inside our network are still safe from that. And as you know, you have also quite a number of attacks against IPsec VPN concentrators, all the IKE, Ego Station attacks and so on. So that was still a challenge, and we're still looking into that one. But I think that's, going forward, more and more customers are actually going to ask for it. What's the future like? The future is IMS services. As I said, IMS is all this fancy multimedia stuff you see on the cell phones, especially. It's mainly driven by the mobile operators. I don't know if you guys remember 4, 5, 6 years ago when all those operators were deploying their WAP services. Okay? You get a nice IP address, 10.20.30.40. Okay? So you install Nmap on the client, you launch Nmap, and you realize that actually those guys connected their WAP gateway with the IT network. So we have some example of providers. There's one in Switzerland actually. They actually connected a 3G network with the IT network. So you just need to be able to install the right application on your terminal, because the terminal was trusted. Cell phone. Who is going to install something on a Symbian, cell phone? Well, some people actually did. So you can find some really, really funny things. IMS. I'm not going to go into the details for that one. I could do a 2-hour presentation only on IMS. It's really, really complex. I mean, if you guys want to spend some time, I really recommend you look into it, because as complex as voice over IP itself is, the few examples I've shown, I mean, IMS is that one factor 10. So it's crazy. The attack surface is really, really large. You have registration servers, you have application servers, the ones that are going to send the nice music and a different ringtone and stream the media to your cell phone, and the one that holds the user base, and using 25,000 different protocols, and you cannot firewall them anyway because you're going to break everything. So the IMS core, I mean, I have no idea yet how we're going to secure that one when we're going to deploy it. So I'm still hoping for somebody to actually come up with an answer for that one. And the next thing we want to try, but I didn't have time before the presentation, is to attack fixed mobile handover. So you probably heard about FMC, fixed mobile convergence. You have a cell phone that does wireless LAN and GSM. And when you're in the enterprise, you're going to use Wi-Fi. When you go outside, the call is handed over to the GSM network, and you can even keep the call and so on. And everything is driven by the cell phone itself. So it can be quite funny, because Internally it will be clear text. Usually, you don't run a web, internally on those access points because the cell phone doesn't support it anyway. And then outside GSM is encrypted. And breaking GSM, live, you need quite some kit. You need to be one of those guys with no name on the badge. So what can be quite funny, if you know the guys around, just set up a fake wireless LAN and you try to force a handover from GSM into wireless. So you could actually listen into the conversation without the guy even noticing it. But something to try, right? We managed to do it in the lab, but the lab is no fun because it's perfect conditions. But I think that's going to be a fun one. Listening into your boss's conversation when he's in the office and this type of things can be really interesting. Okay. Yeah, nearly on time, even sometimes some questions. I hope you guys learned something. I really tried to keep that one simple because, it's really damn complex. And I wanted to show you the different threats we have been, dealing with the last couple of months, deploying all the systems. The walk-ons, we've found that we have deployed the ones we're still working on. Again, at the end of the day, what I can tell you is from network point of view, once the traffic is outside the enterprise network, it's pretty secure. The thing we're struggling with are all the web applications. All the things that are around the voice over IP network itself that provide additional services, those are actually very difficult to deal with. And we're going to see more and more deployment. Voice over IP, you're going to see everything is moving into the voice over IP world. All those larger carriers are going packet core. They want to get rid of the 25 different networks they run. They want to carry everything over IP. So what you're going to see in the next 5 to 10 years is voice over IP everywhere. Maybe it's not voice over IP facing the client, but at least the core on the provider side is going to be voice over IP enabled. So we're going to see some more fun. Okay, that was it. Do we have any questions?
When you brought up the topic of patch management and mentioned that some vendors don't make it easy to do patch management or even block you from doing it, could you tell us a little bit more about it? What vendors are you referring to and exactly?
What was the end of the question? I didn't hear the end.
You mentioned patch management,
yeah.
And I wanted to hear more about specific vendors.
Yeah, it's it's mostly any vendor. It can be some single thing that happens at some point, and that you can solve by contract. And you have also vendors that just say we sold it that way. That's a system you bought. It's being managed. You're not going to touch it. I would say any vendor has the same game running at some point, saying well, if you patch it, it's going to break those things. We will not be able to support it. Some of them are just being more difficult to deal with, but any of them has actually this kind of policy. That's all I can say. Coming up with names, I don't think it's going to help, but yeah. No.
Yeah. You mentioned that DDoS wasn't an issue, or because they don't have access to the core. What about public voice over IP carriers that, like registration servers that are externally exposed and things like that?
I'm really happy to not work for them because I have seriously no idea if somebody like Vonage, Packet 8, any of the SIP providers get attacked, how they're going to deal with it. Because the only way would be have one of those washing machines, being in the Cisco guard or tipping point, top layer, whatever in front. But I don't think they can either cope with it, decode the right stuff, or not break more things. And I'm really surprised that we haven't seen any larger SIP carrier being attacked more often. Because I'm seriously wondering how they would defend, because it's really complex. It could just be it could come from everywhere. SIP is UDP based for most of it. And it's really not, and as we know, dealing with UDP traffic in the DDoS attack is really not easy. That's all I can say. I really have no experience, but if I've been in that situation, I think I would have a hard time dealing with it. Yeah.
Kind of along the same lines, I did some work on UMA
And with when you spoke briefly on IMS, you said the attack surface is relatively small. They can only attack the VPN concentrators. What prevents someone from connecting to the VPN concentrator with legitimate credentials and then attacking the core network? Because in the UMA research that I did, there was no real firewalling or access control once you've connected legitimately to the core network.
Well, yeah, I mean, at least, I mean, if the person is trusted at some point because you got the credentials, at least you can trace it back, you know. And but you know, that's the risk model or the risk management model. You know, if the customer is sitting inside your network, at least you can do something about it, maybe able to trace back, you know, look at it. But if he's got the right credential, you know, yeah, right, he's in. There's nothing you can do about it.
I wonder what your opinion is of the longevity of Skype. I've been using it for three plus years. I like it a lot, but my jaw dropped when I read that eBay paid $4.1 billion for it. I just can't figure that out.
The thing is, I mean, Skype is going to stay because the thing is with Skype just works, right? That's what's fantastic with Skype. I mean, you install it, it just works. The fact that it abuses resources from people that have more bandwidth is probably a limitation. I think it's going to stay around. I mean, except if eBay kills it, you know, with, I don't know, advertisement in it or make it more complex to use or whatever. But I think it's going to stay around for quite some time. And as you may have seen from some of the presentations at Black Hat, you know, the Skype people have made it quite complex for people to reverse engineer the Skype client with all the obfuscation they've done, all the tricks to protect from debuggers and whatsoever. So it's going to stay around. I mean, it was funny. I think last week or 2 weeks ago, some Chinese company actually published, you know, something that some people said is reverse engineering of the Skype protocol to make it possible for other, you know, clients to join the Skype network. I mean, why not? But I think Skype is going to stay around.
Question: do you feel like the environment that you're going to be in is going to provide more direct end user services, residential or whatever, or is going to be more of enterprise trunking? Which do you think will predominate?
I think it's hard to say. I mean, our case, I mean, we only sell the services to enterprises, so we don't do, you know, the end user market at all. So for us, it's pretty clear. You know, we're going to focus at least on migrating all the existing services to the voice of IP world, and then, you know, we're probably going to provide, you know, using IMS core new services like presence, IM, integrated messaging, and so on. But there's, I don't know in the US, but in Europe, there's a clear trend by most of the DSL and cable providers. You know, they're talking 4G. You know, there was triple play, right? They're already talking quadruple play. So you get DSL access, internet access, TV, phone, and then all the services on top. You know, media streaming, and you know, all these type of things. So there's a clear demand there. The only thing is, I mean, what I don't get is the business case. You know, how can you sell, you know, triple or quadruple play services for 30 euros a month and make money at the end of the day? You know, it's a completely different thing. You know, you get everything for free. You know, free phone calls in the network. If you call landline, it's free or it's so cheap. I mean, there's a huge demand, and I'm really wondering if they're going to survive it in the longer term. You know, what kind of, you know, value-added services they will put on top of this of those hardware deployments that are very expensive.
You mentioned discovering a protocol, I guess, SIP datagram that killed the SBC 3 or 4 days after the fact.
Yeah.
How did you find that out? How much suffering was involved?
The way we found out is running sniffers 24/7 and looking at this. We were running sniffers 24/7 on the link, and actually it was in MGCP. When you do address of charge, you have this MGCP backcall from the soft switch to the voice client, and that one was actually causing the trouble. So it's just, you know, sniffing 24/7, taking everything out, and we looked at, I don't know, gigabytes of logs already. I mean, as a real, we cannot see it anymore. It was our tool of use, like 10 hours a day at some point. But it's difficult. I mean, debugging voice over IP is, believe me, is a nightmare.
one last, are there any SIP firewalls that have ALGs that are worth a dime?
With the what?
Worth anything, that are worth deploying?
Oh, worth deploying. As I said, I mean, most of the major vendors that have been around, you know, that you see, all the market leaders, they have quite some good ALGs, being it for SIP or H2 or MTCP. I was pretty surprised because some of those vendors, which are, you can say, you know, it's something generic, the firewall, you know, it has to deal with so many different protocols, are actually better than some of the SBCs. And the SBCs are dedicated for the VoIP environment. So if you take, I don't know, checkpoints, Cisco Pix, you're going to hear names, you know, whatever, you know, they're pretty good. They're really good. And some SBCs, you know, could learn from them. I was surprised. And some of our voice guys were also surprised, you know. Yeah. No more questions? Okay. Thank you, guys.